Hello everyone, so today we're going to go over section 4.2, factoring polynomials. So we'll begin with a review on how to factor trinomials that are degree 2. So one way to factor this is to factor by grouping. So we'll notice that the middle term here, 7x, so we are looking for two numbers that add up to 7 and also have a product of the leading coefficient of 6 times the constant of -3. So a times b is equal to -18. So we will have that a is equal to 9 and b is equal to -2. Okay, so the next step is to separate the middle term 7x into those two parts. So we have 6x squared plus 9x minus 2x minus 3. Next, since this is called factor by grouping, we'll make two groups. The first group will be 6x squared plus 9x. And the second group will consist of -2x and minus 3. And we'll factor out the greatest common factor in each group. So in the first group, we have 3x. And we'll be left with, here we'll be left with 3x minus 1. Sorry, 2x plus 3. Sorry about that. And here, the second group will have a factor of just -1 that we can factor out. And the leftover parts will still be 2x plus 3. Okay, from there, we can factor out the 2x plus 3 from the first and second groups. And so the final result of this factoring is 2x plus 3 and then 3x minus 1. Okay, so that's one way of factoring, again, that is called factor by grouping. Okay. The second way of factoring that we might have seen is we're going to show that in example 2 here. So first of all, notice that there's a common factor of x, so we'll factor that out first. So we have x times 2x squared minus 3x minus 14. All right. So one way to factor faster is to consider this crisscross method. We have 2 and 1, which are the factors of 2. And we have also the factors of -14 are 1 and -14, -1 and 14, -7 and 2, and then 7 and -2. All right, so in this case, if we have, let's say, 7 and 2, like so, that gives us a product of -14. And then if we crisscross these over, so 1 times -7 and also 2 times 2, what results from that is, of course, -7 and a 4. And if sum of those two numbers is -3, which matches the middle term. Okay, so what that tells us is that the two factors that factors the trinomial are 2x minus 7 going across the top row there, and then x plus 2 going across the second row. And that's a second method of factoring that we may have seen before. So when it comes to doing question, either way is fine. Any factoring trinomial techniques that we might use are okay. Okay. So we're going to expand on the idea of factoring polynomials to factoring cubic polynomials. And that has to do with dividing polynomials, which we saw in the previous day, and also the remainder theorem. So this question here says, what is the remainder when x cubed plus 2x squared minus 13x plus 10 is divided by x minus 2? So there are a couple of ways of looking at this. Number one, simply use the synthetic division that we saw in the previous day lesson. So of course, here we have 2 on the left hand side, and then the coefficients 1, 2, negative 13, and 10. So 1 gets carried straight to the bottom. 2 times 1 is 2, 2 plus 2 is 4, 2 times 4 is 8, and then negative 13 plus 8 is negative 5. 2 times negative 5 is negative 10, 10 plus negative 10 is 0. So the quotient is x squared plus 4x minus 5. Okay, and the remainder is 0. Okay, so that's one way. This is again synthetic division. So if we are not interested in finding out what the quotient is and just want to find out what the remainder is, then synthetic division is not necessary. We can use instead the remainder theorem. So the remainder theorem simply says if we have a polynomial and we want to find out what the remainder is if we divide it by x minus a, we simply have to substitute a into said polynomial. So we can rewrite here x minus a. So in this case, of course, a is 2, so we can substitute 2 into the polynomial. So 2 cubed plus 2 times 2 squared minus 13 times 2 plus 10. Whatever this number is, that is going to be the remainder. So we have 8 plus 8 minus 26 plus 10, which is actually 0. So that matches the result that we got from using synthetic division, which is good. So furthermore, we have a corollary here of the remainder theorem, and that is for if a is an integer, x minus a is a factor of the polynomial p of x if p of a is equal to 0. So in the example that we just saw, x minus 2 is a factor of x cubed plus 2x squared minus 13x plus 10 because it divides evenly. Okay, so instead of having to divide every time, we can simply use the remainder theorem, and if the result is 0, then the x minus a is a factor. Okay. So just a quick note here says, determine whether x plus 2 is a factor of each polynomial. So in these two cases, a is simply going to be equal to negative 2, and we'll substitute it into these two polynomials. So here we have negative 2 cubed plus 2 times negative 2 squared minus negative 2 minus 2. So that will give us, of course, negative 8 plus 8 plus 2 minus 2. So that will, of course, be equal to 0. And so this is yes for x plus 2 being a factor. Now, again, we don't know what the quotient is, but we can find that out by using synthetic division. Likewise here, substitute in negative 2. So we have negative 2 to the 4th power minus 3 times negative 2 cubed plus 10. So that will, of course, be 16 plus 24 plus 10. And that will not be 0, that will actually be 50. So x plus 2 is not a factor of this polynomial that we started with, so that's a no. Alright, so next up we have what's called the integral zero theorem. If x minus a, where a is an integer, is a factor of a polynomial, then a is a factor of the constant term in that polynomial. So what does that mean? Well, in example 2, we have two polynomials here. What are the possible integral zeros of each polynomial? So x minus what number could be a factor of these polynomials? Now, could be. It doesn't mean that it is, right? So in this case, the constant term is negative 27, so we're simply examining or looking at what are the factors of negative 27. So the factors of negative 27 are plus or minus 1, and also plus or minus 3, plus or minus 9, and finally plus or minus 27. All right. Likewise, for the second example, we have a 10 here. So the factors of 10, we also have to consider negative possibilities as well. So here we have plus minus 1, plus minus 2, plus or minus 5, and plus minus 10, or more accurately, positive or negative, and those integers. All right, so what does that all mean? Well, we've taken all of this together. It allows us to factor cubic polynomials. Okay, so we're going to use the integral zero theorem to find a list of possible integers values for the zeros. Then we apply the factor theorem to determine one of the factors. Then we divide to find the remaining factor, and then we repeat until we have a trinomial that can be factored. Okay, so we are going to look at, let's see, 3 examples here. Now, in each case, the steps are very similar. So in the first one, we have a plus 6 here. So we're looking at the factors of 6, both positive and negative. So that would be plus negative 1, positive negative 2, positive negative 3, and also positive and negative 6. All right. After that, we will try to find a factor that works. So we will substitute in, let's say, for example, 1 into this polynomial. And if we get a 0 as a result, then x minus 1 would be a factor. So that will give us 2 minus 9 plus 7 plus 6. So that is not 0. Okay. As long as it's not 0, we don't really need to determine what the number is. The number in this case is 6, and 6 is not 0. So let's say we move on to, for example, let's try 2. So we have 2 times 2 cubed minus 9 times 2 squared plus 7 times 2 plus 6. So in this case, that will be 16 minus 36 plus 14 plus 6, and that is indeed 0. So what that tells us is x minus 2 is a factor. Okay, and we only have to find one factor, since what follows is using synthetic division. Okay, let's just do this to the right here. So in this case, the coefficients were 2, negative 9, plus 7, and 6. And of course, the number on the left-hand side here, a is 2. So let's use synthetic division. We have 2. 2 times 2 is 4, and this gives us negative 5. 2 times negative 5 is negative 10. Add together gives us negative 3. 2 times negative 3 is negative 6, and we have a remainder of 0, as we expected. And so the quotient is going to be 2x squared minus 5x minus 3. And of course, then the question is 2x squared minus 5x minus 3 factorable? So it's going to go to the next step. The factors of 2 are 2 and 1. And the factors of negative 3 could be, let's say, 1 and negative 3. The idea here is if we kind of cross multiply here, we get a sum of negative 5. So 1 times 1 is 1. 2 times negative 3 is negative 6. And add together is indeed negative 5. So the two factors of 2x squared minus 5x minus 3 are 2x plus 1 and also x minus 3. And so taking all 4 steps together, so the first step was, of course, finding the possible factors, determining one that works, and then synthetic division, and finally factoring the resulting trinomial. Taking that all together, then, of course, the original cubic polynomial is now factored completely. We have 2x cubed minus 9x squared plus 7x plus 6, and that is equal to x minus 2, the first factor we found, and then the 2 factor 2x plus 1 and x minus 3 from the factoring of the trinomial. And the whole idea is if we multiply all 3 of those binomials together, we'll get back to the original cubic polynomial. Okay, so let's look at another example. So in this case, we have a nicer constant. It's just plus 2. So this will mean that the numbers we have to try is only just positive and negative 1 and positive and negative 2. It's going to go ahead and try negative 1 right away. So, sorry about that. 3 times negative 1 cubed minus 4 times negative 1 squared minus 5 times negative 1 plus 2. Let's see what we have here. This will be the same as, or equal to negative 3 minus 4 plus 5 plus 2, which of course is equal to 0. So that means x plus 1 is a factor. So that's step 2. Step 3 is the synthetic division step. Let's go ahead and do that here. Oops, that's the wrong color. So I'll match it with the previous example so it's a little bit easier to read. Okay, so in this case, we have the coefficients of 3, negative 4, negative 5, and 2. And the number on the left-hand side that we'll write is negative 1, right? Since x plus 1 is the same as x minus negative 1, so that's the number that we will use. So synthetic division, carry the 3 down. Negative 1 times 3 is negative 3. Negative 4 plus negative 3 is negative 7. Negative 1 times negative 7 is 7. Negative 5 plus 7 is 2. Negative 1 times 2 is negative 2. 2 plus negative 2 is 0. So that works. And our quotient is 3x squared minus 7x plus 2. All right. So from there, we can factor. Again, factoring by grouping is entirely possible, but here we're just going to go 3, 1 are the factors of 3. Now in this case, we are looking for a negative middle term, and the constant term is positive. So that means we have negative components there. 3 times negative 2 is negative 6. 1 times negative 1 is negative 1. And add together is negative 7. So that is going to work for us. Let's go ahead and write that down. So the factors will be 3x minus 1 and then x minus 2. And again, now that all 4 steps have been completed, we can find out what our answer is. So 3x squared minus 3x cubed minus 4x squared minus 5x plus 2 is equal to x plus 1, the first factor we found, and then the 2 factors from the trinomial. So 3x minus 1 and x minus 2. Okay. One more. So this one's a little bit more involved, since the first term is degree 4. And another troubling part with this is 36 has a lot of possibilities. So 1, 2, 3, 4, 6, 9, 12, and 36. So that, 18 and 36. So that's a lot of numbers we have to test. So in this case, usually if this is what we're going to ask, probably going to give you the first factor just to make things a little bit easier. X minus 3 is a factor. So that will take us to a cubic polynomial after the division. And if we kept going, this whole polynomial is actually equal to x minus 3, x minus 1, x plus 6, and finally 5x plus 2. And so we'll try to factor this at our own time and see if we can come up with that answer. And that's it for today, so thank you for listening.